Well, hey there, folks. Welcome to the final part of our workshop on ISCC in practice. My name is Chuck Ellis. I'm the digital marketing director here at AmSpec Group, and I'm really excited to talk with y'all today about this process and introduce our speaker, Rodrigo Otero. But before we do that, I want to let everybody know that there is going to be a recording sent out to the email addresses that are registered for this event. So if you've got colleagues or friends that you would like to have view this presentation, you can send them the registration link that you signed up for, and that will automatically put them in the system to receive a replay. So if this is useful to you and your team, that's a good way to have it sent around. Also, later in the week, I will be sending out an email. So look for an email from me linking to the replay to access that, and you can share that as well with your team. If you have any questions, the chat is turned off for this presentation. If you look up at the top, there's a little section called Q&A that you can use to ask us questions during the presentation, and they will be addressed at the end of the presentation. So for those who don't know about AmSpec Group, we are a testing, inspection, and certification company. We operate in at least 75 different countries, a little bit more, I believe now. We're always adding new labs and services, and we do specialize in sustainability and ISCC type certifications. I will quote from our website here because it says it better than I can. But at AmSpec, we specialize in sustainability, certification, and consulting, helping businesses navigate the complexities of ISCC EU, ISCC Plus, and ISCC Corsa certifications. Our mission is to support organizations in achieving their sustainability goals through internationally recognized standards for biomass, biofuels, circular economy materials, and aviation emissions reductions. So we can help you with all of that stuff and a whole lot more. We work with LCFS, we work with EUDR type certifications. Basically, if it has to do with sustainability, we can help provide you independent third-party accredited testing to help you get done what you need to get done and prove to your stakeholders that you are taking a serious step towards zero emissions or sustainability-based practices. So again, thank you for being here. Use the Q&A function. We will address those questions at the end of the presentation. Don't worry, we're not forgetting about you. And if for some reason we don't answer it during the presentation, we will reach out to you via email and answer your question privately. So without any further ado, real quick before we go, make sure you're following us on LinkedIn if you aren't already. You'll see updates for future AmSpec Academy sessions that we are going to be doing. We got a lot more stuff to talk about, and Rodrigo is a wealth of information, so we can't contain it all in just 2 1-hour-long sessions, so expect to see more from him in the future. So check that out. Visit amspecgroup.com, and if you find us on YouTube, make sure you like and subscribe, because that's a really helpful way to see what is going on in the world of sustainability and testing. So without any further ado, I'm going to turn things over to Rodrigo. Thank you, Rodrigo. Let's have a great presentation.
Thank you, Chuck, for the introduction, and hello, everybody. Welcome to the second session of this webinar. So today what we're going to try to do is to give a better understanding of a few key aspects of audits, and of course, we're going to see how the implementation of an ISCC system is in the actual practice on an everyday basis for any kind of company. We'll try to cover a few of, like I said, key aspects of a certification. However, we'll try to keep it a bit shallow, let's say, and not too much in depth as a revision, just to make sure we cover every aspect of an audit. So today we will be looking into 3 main aspects, which are the traceability, the mass balance, and the greenhouse gas emissions calculation. So for the mass balance, we're also going to see 2 practice cases, one for a collecting point and another for a conversion unit. And when we get to the GHG calculation part, we're also going to see everything that we are going to review on a record basis, on theoretical basis, in practice for an example of a biodiesel plant. Again, everything that's on a documental basis and presented on these slides is going to be updated as of today. Of course, the legal framework might be subject to modifications in the future. So just to begin with the traceability of it all, which is a key aspect of an ISCC certification, we would first need to have a better understanding of what ISCC aims to accomplish with their certification. So ISCC basically guarantees the sustainable practices and reductions in the GHG emissions through a worldwide supply network. Okay, there are three major aspects that always are respected through any certification under ISCC, which are the verification, of course, of the reduction of GHG emissions, which we will later specify when those conditions are met or not. Of course, the aspect of the traceability of these materials, which is the general concept of being able to trace, as the name indicates, the sustainable information of the incomings to the outgoings of any system user. And of course, as well, the sustainability in feedstock productions. Of course, ISCC is compromised with making sure that there is no deforestation and there is protection of high carbon stock land. Okay. So moving into the next slide, we can see a general overview of what a general supply chain can look like. There are two origin, let's say, for these supply chains, depending on the material that the certification is aimed to handle. If we are talking about agricultural and forest biomass and residues, we talk about a point of origin called farm or plantation, okay? And when we get to the waste or residues, renewable non-bio feedstocks, we always talk about a point of origin of the residue or waste that is going to be handled. Each of these materials are then delivered to what we call a first gathering point for the case of a farm and plantation, and what we call a collecting point for the case of the point of origin for waste or residues. Just to give you an idea, for example, a point of origin or for a waste or residue could be a restaurant that generates an amount of used cooking oil after frying some food. And that used cooking oil is then delivered to what we call a collecting point, which is it's a general waste manager that gathers the material and stores it intermediately, okay? So when we have the sustainable material from either side of these supply chains, that is usually delivered to another scope of certification, which is a processing unit. The processing units are in charge of handling this sustainable material and generating with it a final product, okay? This is what we call, for example, in the case of a biodiesel, a biocarburant, okay? Now, these processing units usually have an intermediate economic operator between them and the market of consumption, which is what we call a trader. A trader can have external storage capacities at different locations or even in an on-site storage capacity. Any of these scopes of activities can be certified under ISCC, of course. There are general audit requirements that apply for any of these activities. For example, each of them needs to have a management system in place that allows for them to make sure that they can deliver the results necessary for a successful audit result. And of course, they need to make sure they have the traceability documents and mass balance to prove that this traceability aspect of the audit is complying with the requirements. Of course, the GHG emissions aspect of it all is going to be a requirement as well. Now that we have the general knowledge of what the traceability throughout the supply chain is, we can dive further into the mass balance. So as a general introduction, when we talk about traceability, for you to be able to demonstrate the traceability of this material, you need to apply what we call a chain of custody, okay? A chain of custody model. This is the way that you will be able to demonstrate that the traceability requirement is being fulfilled. Now, these chain of custody models can be different ones. Mass balance is not the only one, but the most used one. So, for example, we could talk about physical segregation as a different chain of custody, but generally speaking, all these chains of custody share the same concept behind them, which is for you to be able to keep track and have the records to demonstrate the flow of the sustainable feedstocks, the flow of that material, as well as the ones for non-sustainable feedstocks. You have to be able to demonstrate that there is no crossover between these two kind of records, and of course, that you are not incurring it in any multiple accounting practices, okay? So if we go to the next slide, we can see a couple of very important aspects of the boundaries of a chain of custody. So for a mass balance, these kinds of records need to be site-specific. Of course, any kind of location or operating site that is covered under an individual certificate needs to be in compliance with the mass balance. They need to have their own mass balance, okay? So basically, they need to keep records of what's coming in and what's going out. Any company that has multiple certified sites or scopes, they must keep separate balance for each of them, including scopes. Like I said, if there's an operating unit that has several different scopes, which they are being certified for, individually certified for, they must be certain that they have separate records for each of these scopes. And again, a key aspect of an ISCC requirement is that there has to be evidences to prove that there's a physical link to material, okay? We always look at delivery documentation when we audit a system user. We have to make sure that if there is an incoming batch of material in a mass balance, we need to be able to demonstrate through evidences that there was a physical movement of it, okay? So practices like an instant transfer of material from one operating site to another is not allowed under ISCC EU. These kind of practices, for example, can be covered under other schemes of certification like ISCC Plus. But again, for the ISCC system that is recognized for the compliance of the Renewable Energies Directive, a practice of an instantaneous transfer is not allowed. Now, a key aspect again of the mass balance is that these ones need to have a maximum period defined. They need to make sure that you close the stocks of any sustainable material in a period that cannot go over the 3 months, okay? Any scope of audit needs to close this mass balances every 3 months or less. They can choose for a shorter mass balance period as long as they keep it updated regularly. With the only exception, of course, of first gathering points, because first gathering points receive or collect their material from farms and plantations. And this kind of points of origin for sustainable material usually have an activity that goes yearly. So we have 4 different seasons. Usually you harvest on one of them, and therefore you keep your mass balance with a maximum period of 12 months to make sure they align with certification requirements. Now, these mass balance periods must always be continuous. We cannot ever skip a mass balance period, even if it doesn't have any sustainable movements of material. So you would just keep your mass balance period on a 0, so no movements, but you do need to make sure that these ones are continued. And again, it's mandatory that you keep the records of the dates from start to end of each period, and of course from the incomings and outgoings, very well documented. Now, when we talk about an audit that can be applied for any scope of certification through the supply chain, there are a couple of requirements and principles, we could say, that are shared all throughout them, okay? These ensure the integrity and prevent fraud through the activities of these kind of companies. So one of these is, of course, the sites and balances, which we were previously discussing. All certified sites need to be identified, and of course, each of them needs to have a well-maintained mass balance independently. This means that if there is a certification for an individual warehouse, this warehouse, of course, even though they do not own the sustainable material because they only provide storage service for another company, they must be certain that they can keep a well-maintained mass balance to comply with the requirements of ISCC. Another principle is the material tracking. This is basically the concept of the traceability that we were previously discussing. There has to be a complete account of all material inputs and outputs per site, including, of course, the sustainability status of the material. There could be scenarios where material changes their sustainability status because of commercial reasons, for example. You could have an incoming of a sustainable material, but afterwards you decide that you don't want to sell that as sustainable. So that is a possibility, but of course the records need to show that was taken care of accordingly to the requirements of the standard. Of course, we need to make sure that at the data integrity, we need to validate, for example, the information that is provided as evidence for the conversion factor calculation. So again, we're going to see it in the next slide, but one of the major aspects of the mass balance calculation relies on the conversion factor. This is a factor that establishes the relation or the ratio between the products and the feedstocks. And for certain scopes of audits, this is very relevant to determine the sustainable share of credits that you will have after the processing of the material. So about the period integrity, of course, any revision that an auditor does towards a system user is referred to a specific and static period. We always establish an audited period. We determine the basis of calculations for a GHG calculation methodology, and therefore we always refer the result of the audit to a period itself. So we must make sure that all records are very well dated, and of course the integrity of the period is very well established. Now, both for the mass balance calculation and the GHG calculation, we will need to make sure that the formulas behind it, so the math verification, is consistent and correct. There can be modifications from one year to the other, specifically due to perhaps the regulatory framework changing or being updated, but it's very important that the auditor has access to the records to make sure that either the math, so the formulas behind each, for example, Excel files, is consistent with the regulatory framework and, of course, the GHG calculations as well. When we talk about traceability and the mass balance that needs to be kept for any of these activities, there's a concept called claim integration or even aggregation of sustainable batches. This is the idea that if you have several different batches of sustainable material that share all the sustainable information, you can aggregate them. So you could have, theoretically, 5 different incoming batches that are individually certified. And it's very tricky. It's not a regular scenario, but if they all share the same sustainability information, you could aggregate those batches just to issue one outgoing lot of material. This has to be very well kept on a mass balance, and of course needs to be very clear for you to demonstrate that there is no double accounting. That is exactly the next principle that is shared all throughout the supply chain. There needs to be evidence to be able to review and guarantee that the materials are not counting under multiple schemes. This could be a possibility for a system user that is certified for more than one sustainability scheme. For example, there has been cases in the past of fraudulent activities, of course, and not allowed by ISCC, where a system user purchases one single individual lot of material, sustainable and covered, for example, under ISCC, and decides to issue 2 different proofs of sustainability for that outgoing material into different systems. That is a practice that is not allowed under ISCC and deemed fraudulent. And once again, the last aspect that is shared all throughout the supply chain is the full scope principle, where all operating sites need to be individually audited when they are linked to a certificate. They have to be included. Perhaps I might rephrase that, not needing to be individually audited, but at least reviewed on a sample basis from the audit perspective. So, for the mass balance calculation, now getting into the formulas, we have here the general overview of what the mass balance credits have to be calculated with. So in this formula, B is a total available sustainable material for the period. When we talk about incoming sustainable feedstock or the inventory of sustainable feedstock that was available at the beginning of the period, we need to make sure that we multiply those two added to the conversion factor, which again is site specific. This conversion factor again will determine the ratio between the feedstocks and the products. And of course, we always add on top of that the inventory of sustainable product at the beginning of the period. Yes? This formula will determine the amount of credits that you have available at a mass balance period. So any outgoing sustainable movement in that period has to be less or equal to that amount, because a negative balance is not permitted. Now, I mentioned previously the sustainability information. Okay, the sustainability information is, let's say, a pack of data that comes along with a batch of sustainable material. This pack of data basically contains all the information that a system user needs to know to make sure that they can account for the sustainable batch as sustainable accordingly. These include the type of raw material, the country of origin of the raw material, which let me specify, it's different from the country of the origin of the last displacement of the material. So the movement, the recipient of that material, perhaps the origin of that displacement can be from Netherlands, for example, but the origin of the material could be from Algeria, okay? So again, it has to be referred to the country of origin of the raw material. Then we have the type of product, indicating whether or not it's a biodiesel. Perhaps it could be a refined oil. Perhaps this could be an HVO or any other kind of biofuel. It has to indicate the certification scope, of course, the GHG information, and the claim or whether or not this material is ISCC compliant or EU RED compliant. So when we talk about sustainable material, it has to be demonstrated that batch of material is EU RED compliant. That is mandatory. If it is not complying with the EU RED, it's not going to be sustainable. Now, the ISCC compliant claim goes a bit over that one because it means that it's not only sustainable, but the whole supply chain has been covered under ISCC certification. You might remember from yesterday's webinar that there are different systems for compliance with the Renewable Energies Directive and that are recognized for the fulfillment of those requirements. However, those systems, being that they are mutually recognized, can certify different batches of material. So the sustainable material can jump from one supply chain to the other, being claimed as sustainable, but of course not ISCC compliant. Like here, the phrase indicates the materials with the same sustainability characteristics can be kept in one individual mass balance. A free combination of sustainability characteristics, of course, is not allowed. Like I mentioned, the practice of aggregating sustainable batches is allowed, but it has to be done with very rigorous requirements. So, we discussed a bit of the key aspects of what a mass balance is, and perhaps it would be very illustrative to just jump and dive into the collecting point exercise. Here we're going to see a collecting point that collects not only UCO, but also brown grease. So we're talking about an individual company that gathers two different waste to residues materials. So we're going to see how the records need to be kept and how you perform the calculations to make sure that you do not sell more than you can. So on this slide, we can see two different tables. So the list on the left is a collection list. Basically, it's the records of the company indicating when and where they collected sustainable material from. Okay? We can see dates and, of course, general names of restaurants here indicated as R1, 2, 3, and so on. It also indicates the quantities collected, for example, for used cooking oil and for brown grease. And this registration, this logbook, let's say, also keeps records of the distance transported from the restaurant to the collecting point. This will come into relevance for the GHG calculations we will see afterwards. On the right, of course, you can see the outgoing batches, and this is a reference to the sustainable batches of outgoing material that the system user is going to claim for this specific audited period, which is, of course, the first quarter of 2025. Here we can see that the system user stated sustainability declaration numbers for the two outgoing lots. These lots are, of course, referred to UCO and brown grease because these two materials need to be kept separate because they have a different raw material, indicating that they have different sustainability information. And then we see a reference of how the GHG information is going to be presented. We have disaggregated default values, that is what DDV stands for the UCO, and we have actual values for the brown grease. Now, being that the brown grease has actual values, they need, of course, the information about the transport distances. And we can see that they stated 945 as a total distance of transport. These two batches of material go to company A and company B. And of course, they refer to the quantities that each of these lots is certifying, okay? If we move to the second slide, we're going to see the overall mass balance for the period that we were just reviewing. This is basically the result of the formula that we have presented for the calculation of the sustainable credits that you are allowed to sell. If we look at the table on the left, we can see the UCO overview of the mass balance for this period. So we have indicated the initial sustainable stock as well as the non-sustainable stock. We also have collections of sustainable material and non-sustainable material. And one concept that is very relevant for collecting points that deal with UCO is the losses of the process. This kind of material that you can imagine it's quite dirty, it has to be subject to filtration and decantation to make sure that it has a better condition and better quality to be able to sell to a final customer. So this material is subject to losses through the process that a collecting point is allowed to perform. And then you have the amount of material that was sold under ISCC, as well as the material that was sold as non-sustainable. Now, if you do the addition and subtraction of all these quantities, you will be left with a final sustainable stock and, of course, a non-sustainable stock of material. Similar case happens with the brown grease on the right. However, we do not state any losses for this material. And of course, we can see the initial stock of sustainable and non-sustainable, the amounts collected for these two specifications, the amount sold, and of course, the calculation for the final stock. Now, when a collecting point or actually any scope audited deals with both sustainable and non-sustainable materials, they can arrive into a practice that has to be very careful. They need to be very careful because if you collect a material as sustainable with a valid self-declaration and everything according to the system, you are also allowed to sell that as non-sustainable. So the incoming in the mass balance would be sustainable and the outgoing would be claimed as non-sustainable. That can be a practice that is being done due to economic reasons, commercial reasons, or any other aspect. And it is allowed. However, you have to make sure that you get rid of those credits, because if you reach the end of the audit of the mass balance period and there is a lower physical stock of material than the sustainable credits that you have, you will lose those extra credits because you're not allowed to transfer sustainable credits from one mass balance period to the other if there is no physical stock to back those credits up. Now, this example, I think it's quite illustrative from everything we have seen, put it into practice. Nevertheless, you might have seen that the conversion factor applied here is deemed to be unitary. So it's basically 1 because there is no physical transformation of any materials. So we're going to see another example of a mass balance regarding a processing unit. A processing unit that converts raw materials, feedstocks, into biodiesel. This is a very common scenario for us. So first, we're going to have a look at the incoming list where we will see that the company receives 2 different materials, so used cooking oil and food waste, from several different certified companies. And they all have an incoming SD number, which means that these batches of material already come certified as sustainable. Of course, in the mass balance, you have to make sure that you have indicated the country of origin of the material, the quantity. The EP refers to the processing emissions, and then the ETD refers to the transport and distribution emissions. We're going to have a look at that afterwards. And of course, for the batches of material that do not have disaggregated default values indicated as DDV, they need to make sure that they have the information about the transport distances for the calculation of GHG emissions. All these incoming movements are from the month of November 2024, as we can see on the left side of the table. For those incoming batches, we also have outgoing batches. So basically, the processing unit took care of that raw material, processed it, and generated these amounts of biofuel that we can see on this table. Each of these batches of material is covered by a valid POS number. What is a POS? So in the supply chain, when we talk about raw materials, we talk about sustainability declarations. We usually refer to them as SDs. But when we talk about final products, we talk about POSs, which are proofs of sustainability. It's a similar document, but it has a different template from ISCC. So any of these final products, of course, have to indicate the country of origin of the raw material, as well as the country of production of the biofuel, which in this case we can see it is stated as Spain. Of course, we need to indicate the quantities, as well as the processing emissions and transport and distances emissions that we're going to see afterwards how we can calculate those. Now, for us to be able to review the mass balance and make sure that the sustainable material that was produced in this production unit is according to the functioning of the operational unit, we have to review this kind of document, which is a production report. We always ask for processing units to give us the periodic production reports to make sure that we can account for a correct conversion factor. As I have previously stated, this is a very important aspect of the audit because if the conversion factor is incorrectly calculated, it will have an impact in the amount of sustainable credits that the system user has in capacity for them to sell. Therefore, it's very important that these periodic production reports are done either monthly or at least every quarter if the mass balance is kept as such, just to make sure that we have something to review and make sure that conversion factor is aligned with the expected activity of the company. Here, of course, you can see the raw materials that were processed and the quantities that were produced. The link between these two materials, of course, is the conversion factor. Of course, here they also indicate the quantity that was sold from that production lot and the quantity that remains in stock. Now, with all this information, if we account for it through the formula that we see above, we will reach this general conclusion where we can see for the whole last quarter of 2024 that they are indicating the initial sustainable stock of raw materials as well as biodiesel. So in this case, this particular processing unit is not dealing with any non-sustainable material. So we will only look at sustainable feedstocks and products, okay? So the incoming sustainable material is stated as well as the amount of that material that was processed. And then we receive the produced sustainable biodiesel. So we all, of course, need to make sure that they are not indicating that they processed any more that it was in stock plus the incoming amounts. With that, of course, they refer to the amount that was sold under ISCC, and they can, of course, refer to the amounts kept in stock. This is once again kept not only for the UCO, but of course the food waste, because mass balances need to be specific per raw material. Even though here that we have the same outgoing product, so a biodiesel, the records, the logbooks need to be kept separate for every raw material. I think this was a good example for you to be able to see how all the principles for the mass balance and of course the traceability aspect of it is kept on an actual practice, a real company. Now we can move on to the last part of our presentation for today, which is the GHG emissions. Now this part is going to take a bit longer because we first need to introduce the concept of what a greenhouse gas emission is actually. I think everyone is well familiar with the greenhouse effect. I feel like at this point in time, everyone has heard of it. But we have to make sure that we're not incorrectly classifying the gases that we're talking about. So here we refer to greenhouse gases that, of course, are not any air pollutant, okay? We specifically refer to CH4, H2O, CO2, and N2O. So any kind of gas that has a global warming power that could have a repercussion to this greenhouse effect, yes? We can see here on the left a graphic that shows the composition, the percentage of shares of greenhouse gases that it's in the atmosphere. So we can see that it's mainly carbon dioxide, and of course we have methane, nitric oxide, and fluoride gases. Any of these are always referred to and accounted for when it comes to a GHG calculation in tons of CO2 equivalent. That is what the global warming potential refers to. It's a conversion for any of the other gases to translate that into carbon dioxide units. So we can always account for them according to that same baseline, basically. And on the right, of course, we can see the evolution of the concentration of these gases in the atmosphere all throughout the years. I think there's a clear increasing tendency that we can see on that graph. And now that we have a better understanding of what we are trying to account for, we can dive into the methodology of it all. So I mentioned that there were several different recognized systems for the certification of sustainability that were in line with the Renewable Energies Directive. Any of these systems always referred to the same calculation methodology for the GHG emission side of it. So ISCC, again, follows this methodology. There are several differences between different schemes of ISCC, of course. For example, under ISCC EU, it is mandatory for them to calculate the GHG intensities, okay, the emissions of it. But for ISCC Plus, it is voluntary. It can be included in the certification as what we call an add-on. This methodology of calculation, of course, changes depending on the type of biofuel or biomass that is going to be handled, and of course, the targeted market and its regulations, because it's dependent on where you will need to show these emission reductions to. Now, the general equation for the calculation of the intensity of GHG emissions is the one that we can see on this slide. It has several different terms, but if we go all through them, you will see that not all of them apply for all the cases of the supply chain. Here, the first term is the EEC, which is the emissions associated to the extraction and cultivation of the raw materials. Of course, this one only applies for farms and plantations. Then we can see the EI, which is the carbon stock changes caused by land use change. Basically, this is what we usually call indirect land use change. Then we have the EP, which are the processing emissions associated, for example, to a case like the one we have previously seen, a processing unit. We have the ETD term, which is referred to the transport and distribution, and the EU term, which is associated with the use of the final biofuel. And again, like we have terms that add to this intensity, we also have terms that subtract from it. So we have the ECSA, which is the soil carbon accumulation via improved farming practices. That could be a good example. For example, maybe if we have a biogas or biomethane processing unit, this one's usually used as a feedstock, manure, okay? And manure has a benefit accounting for towards the GHG emissions, and it actually subtracts to the intensity of the final bioproduct. So when we have the ECCS, we are always referring to carbon and geological storage of emissions, and the CCR could be capture and replacement of CO2. These two are practices that are a bit more rare, perhaps, on the supply chain of the biofuel industry, but they could come into place, of course, in the future. Once again, all these emission calculations is to demonstrate that the material reaches a substantial reduction of the GHG emissions when you compare that to a fossil fuel. Depending on the fuel or the market itself, that reference of a fossil reference can change, okay? Here we have an example of a typical biodiesel production unit where they need to compare their emissions to the fossil reference. Now, for production units that were operating before October 2015, they need to reach a minimum of a 50% savings. If the installations are newer, perhaps after the October 2015, they need to reach at least a 60% savings threshold. And if the installations are even more modern, they can be subject to a reduction requirement of a 65%. Again, these limits are dependent on the fuel that is being produced and, of course, the date where they began operations. Like I previously explained, all the terms from this equation are not relevant for every single supply chain element. So the cultivation, the land use change, and ESCA is usually referred to the cultivation level. It's dependent on the raw material that's being dealt with and, of course, how it was generated. But then if we talk about ETDs and EP, we're always referring to processing units, which are the intermediate processing units that are in charge of calculating these terms. The fuel in use and, of course, the carbon capture, replacement, and storage could come into relevance, of course, for these scopes as well. And that all leaves us with a final processing unit result, which is indicated in a POS, so a proof of sustainability, and it is a final result of the intensity of a GHG emissions calculation for a batch of sustainable material. We keep mentioning the calculation, and of course, we haven't dived into how we actually calculate these terms. We're going to get to that in a minute, but a concept that is very important for you to be able to calculate these emissions is the emission factor. These emission factors are references, basically values of reference for different sources of emissions that could have an impact in the intensity of the GHG emissions resulting. These emission factors come from bibliography, basically, records, lab analysis, and whatnot, but it always has to be a valid source of information. We cannot choose to use any emission factor. We always have to refer to this Commission implementing regulation that it's indicated on this slide. Basically, this sets the ground rules for all the calculations for different companies. Always refer to the same emission factors. This is, of course, to prevent, let's say, a different calculation, a different result of the emissions if it's dependent on the source of the emission factor that you're trying to use. So this has compiled all the references that are generally used for this kind of companies all throughout the supply chain that ISCC made allowed for us to review. We always need to refer to these ones, and you will going to see in the example that we're going to show next. Like I said, we previously discussed quite a bit of a few key concepts for the GHG calculation methodology, and now we're going to see all that implemented into a biodiesel plant. This is the example we're deciding to go with, because we will not only see the transport and distribution emissions calculation, but also processing emissions calculation. So let's begin with the easiest one, which is the transport and distribution emissions, excuse me. You can see the formula for the calculation on the top right corner of this slide. This is the alternative formula for the transport and distribution calculation. This formula is indicated, of course, in the document, the ISCC 205 document, but it can be found, of course, in the Renewable Energies Directive as well. In this formula, we can see that it's being implemented, it's using the distance of the transport, the efficiency of it, the fuel emission factors, and of course, the amount of quantity transported both in dry content and of course in moist content or wet content. So for the transport and distribution calculation, we're going to separate this calculation into raw materials and products. Keep in mind, we're analyzing a case of a biodiesel plant where they have feedstocks and products. So we need to keep those separate. Let's first look at the feedstocks on the left of this slide, where we can see that they have indicated the distance transported, which it's done by truck, and the quantity transport, of course, in wet metric tons. Again, for the formula that I have previously presented, we need to account for the transport efficiency and the fuel emission factor. These two values come from the reference that I previously mentioned, the implementing regulation that is stated on the right column of that table. Now, with this information, we would, of course, need as well the moisture content of the batch of material for us to be able to calculate the dry amount of material transport. So, taking into account all this information and applying the formula on the top right corner, we would arrive at the result of 24.33 kilograms of CO2 equivalent per dry ton of raw material. So, referring to the feedstock. When we will calculate the transport and distribution emissions of the product, we will arrive at a different result with a different unit of calculation. And for us to be able to directly add the two amounts, we will need to convert these kilograms of CO2 equivalent per dry metric ton of feedstock into grams of CO2 equivalent per megajoule of the outgoing product, in this case, biofuel. So to do that, we need to make sure that we have the feedstock factor available and the allocation factor available. These are two factors that we will afterwards see how they are calculated, but just to give you an idea, the feedstock factor is the ratio of how much feedstock needs to be introduced in the process to get 1 unit of product, always on an energetic basis. And the allocation factor is, again, basically an energetic distribution of how the emissions generated through the process will be allocated towards the main product, which in this case is a biofuel, or towards a co-product that could be relevant for the process. And with those two factors applied, we arrive at a result of 0.787 grams of CO2 equivalent per megajoule of biodiesel. When we look at the right side of this slide, we can see the same calculation performed for the outgoing biodiesel. In this case, we have the distance transported and the quantity transported on wet metric tons. The transport efficiency, of course, and the fuel emission factors are the same because the transport method is the same. And of course, applying the moisture content stated there, we will get to a product transport emission calculation result of 2.61 grams of CO2 equivalent per megajoule of the final biodiesel. We can, of course, add on top of that the feedstock transport emissions that we have previously calculated. And to get to a final transport emissions result, we also need to account for the compression emissions at a refueling station. This is a reference value that comes from the regulatory framework because when we calculate transport and distribution emissions, we have to make sure we're doing a calculation up to the consumption point, which means that the final processing unit also accounts for the transport and distribution emissions of all the downstream transport. Now that we have presented all the calculations for the transport and distribution term, we can move on to the processing emissions term. This one is quite straightforward if you get the concept right, because on this slide, we can see the flow of material, basically, which is the processing of two different raw materials. One is FB, which is fresh fruit bunches of the palm fruit, and the waste from vegetable or animal oils. We can see the indication of the wet tons for each of these and the moist content of these ones. Therefore, we can calculate the dry tons. And always having a reference of the LHV, which is a lower heating value of each of these materials, we can account for the energy amount indicated for each of these materials. Now, the products, of course, are referred to as biodiesel, as a final product, and a refined glycerin that comes from process that is not a final product. This is an intermediate product that could afterwards be sold for any other company to apply to the process. With the wet tons and of course the moist content, we calculate the dry tons, and with the LHV, again, reference from the same implementing regulation reference that I have commented previously, we can account for the energy amount of each of these products. Of course, this always has to respect the thermodynamic laws, so we cannot have outgoing energy amounts that are higher than the incoming ones. Therefore, we always have to make sure that this complies with the requirements. Now, the company, to be able to process the feedstocks into the products, they of course need some inputs. These inputs are what we call sources of emissions, basically. So here in this case, we have stated very typical ones, which are electricity, processed water, natural gas, methanol, which is essential for the transesterification of the fatty acids. We have sulfuric acid, and of course, a wastewater treatment that is required for them to be able to dispatch that water. I previously mentioned that the basis for the calculation of the GHG emissions is 12 months. It has to be yearly calculated. So here we see the amounts consumed all throughout that year, and with the correct units in line with the emission factors that come from the references indicated in the right corner, okay? These emission factors, of course, are dependent from the source of emissions and from the reference. Therefore, we always have to try to go for the EU regulation. Now, there are, of course, other references when we cannot find the emission factors on that bibliography. Therefore, we can go to, for example, EcoInvent, that it's stated here on this slide. When we have the emission factors and the amounts correctly stated, of course, always making sure that the units are compatible, we can calculate the kilograms of CO2 equivalent per source of emission just by a direct product. Therefore, we can always add those amounts of CO2 equivalent, and we reach the total emission value for the whole year and all the production of biodiesel in this case. Now, the calculation result is quite straightforward because we have to make sure that we have the correct feedstock factor calculations which are the ones that I previously commented on how they are done. This is the ratio of incoming feedstock per unit of product. Of course, it always needs to be higher than 1. Of course, we have the allocation factors that I previously mentioned, which are calculated on an energetic basis. You can see that most of the emissions will go towards the biodiesel, of course, because that's the main product and it has a higher, not only amount of material, but also a higher energetic content. And we have the conversion factors, again, from periodic production reports of this conversion unit itself. And in the table down below, we present the results of the emissions, the processing emissions, of course, for a biodiesel and a refined glycerin. So to calculate this, we take the total amount of emissions from the previous slide, we apply the factors that we can see above, and we allocate those towards each of the products. The biodiesel, of course, has a higher kilograms of CO2 per metric tons. And when you convert that into grams of CO2 equivalent per megajoule of biodiesel, now you have the correct units for you to be able to add this amount to the previously calculated transport and distribution emissions. The refined glycerin, of course, final result of processing emissions is stated in kilos of CO2 per metric ton because it is not a final product. Therefore, it's going to be stated in a sustainability declaration and not a proof of sustainability. So this would be a general overview of how the calculation of a processing emissions would go for a biodiesel plant. It's a bit of a general example, but I think it gives you a better understanding of how all the concepts that we have discussed are applied in real practice. And with that, I think I've reached the end of my presentation. Of course, we saved a bit of time for the Q&A session. If any of you have anything that you need to comment, I don't know, Chuck, if you received any questions.
We have. Actually,
Wonderful.
we've got one that says, can you clarify the feedstock transport emission in reference to product?
Of course. We can go back to the slide if you don't mind. Here we go. This would be the slide. So let me get the cursor. All right. So we're talking about this table down below here. So we always have to perform a feedstock transport and distribution calculation following the formula that it's on the top right corner. And when we do so, we arrive at a result that it's on a unit of kilos of CO2 equivalent per dry metric ton of the feedstock. Basically, we're talking about a metric ton in reference to the applied feedstock. So if we want to make sure that we present all the results with the same units, so we can add all those up together to make one single emissions and for transport and distribution term, we have to make sure they are on the same unit. So for you to convert this number into this number, which shares the same unit as the product transport emissions that we're going to calculate afterwards, you will need to use these two factors. So the feedstock factor and the allocation factor. Because with the feedstock factor, we convert from dry metric tons of the feedstock into the product. And of course, with the allocation factor, we make sure that we are only accounting for the transport emissions that are referenced to the biodiesel and not the refined glycerin afterwards. So it's just a conversion of units. We're not necessarily including any new source of emission for that case in particular.
All right. Thank you,
Yeah.
Rodrigo. And if anyone has any other questions, let's make sure we ask them in the Q&A section. We've got one more here. Do I understand correctly that in case you have two batches of biomethane products by processing two different sources, e.g. one feed, other waste, they cannot be tracked in the same mass balance document, not aggregated, just inserted into the mass balance document? However, if the biomethane batches were produced from the same source, even though they have different GHG intensity, they can be tracked in the same mass balance document.
That would be correct. So you can keep different GHG intensities batches of the same product from the same raw material, as long as, of course, the mass balance template that you are using allows for you to trace those batches of material. We have to make sure that there is no crossover of those emissions, and of course, no incorrect aggregation of these batches. But yes, the general answer for the question would be that it is allowed.
All right. Thank you. And we have one more. It says, are you planning to give a webinar about the UDB? That's a good question. We could probably do something like that. What do you think?
That is a very good question, actually. Yes, I would suggest that you also, everyone that is interested in it, can go to the ISCC Academy webpage where they have a free webinar that it refers to a UDB, but it might be a bit specific. So we might have to actually jump into that, Chuck, to make sure that we have a more digested version of it for the general listener.
All right, great idea. Thank you, viewer. We'll give a few more seconds to anybody who wants to leave a question in the Q&A section. Thank you for engaging with us on this. And again, remember, you can check out our LinkedIn page where we post a lot of things about ISCC, sustainability, EUDR, LCFS. We just did a webinar on LCFS that was very popular. We had a lot of really good response there. And check out our website. We're in the process of rebuilding our website. We're going to have a whole resources section that you can subscribe to by topic. I'm really excited about that. That'll be coming along very soon. But in the meantime, you can check out our LinkedIn where we have over 43,000 followers right now because we post a lot of really interesting and useful stuff over there. So be sure to check that out. And, are you on LinkedIn, Rodrigo?
I am, sure. Yeah, that's
All right.
my full name.
Go look for Rodrigo over there and give him a follow because he's a good guy and I appreciate his time giving us all this information today. So, okay, we're at 2 minutes till. So thank you for the applause, everybody. We appreciate you all being here. Again, keep an eye on your inboxes. We will be having the replay sent out later in the week. And again, make sure you follow us on all the various socials. Thank you again for your time. Rodrigo, anything else you want to say before we close out?
No, I just want to thank you and everyone here logged in for today's session. Thank you once again for the attention during this hour.